Okay, so we're going to work through some combustion analysis questions. So question number 1 here says combustion analysis of toluene, a common organic solvent, gives 5.86 grams of CO2 and 1.37 grams of H2O. If the compound only contains carbon and hydrogen, what is its empirical formula? So if we're looking at combustion analysis, we're looking at combining that hydrocarbon with oxygen. The oxygen has to be in excess, right? Because we have to have more than enough oxygen available to completely combust that compound to produce CO2 and H2O. And it tells me that it produces 5.86 grams of CO2 and 1.37 grams of H2O. So what we have to think about is in this combustion analysis, we want to figure out what is the formula for this compound, which means that X and Y have to be in units of moles, right? Because then we want to find the molar ratio. Well, one of the things we have to look at is within this complete combustion, all of the carbon from this compound has to go into the carbon dioxide, and all of the hydrogen has to go into the water because there's nowhere else for it to go. So we're going to use that to our benefit so we can figure out how many moles of carbon, how many moles of hydrogen, and then we can find the molar ratio. So we're going to start off with the CO2. And I know that I have 5.86 grams of it. So in order to figure out moles, I'm going to use the molar mass. So I know in 1 mole, there's 44.01 grams of carbon dioxide. So we're going to take 5.86 and we're going to divide it by 44.01. So that gives us 0.13315 moles of CO2. Okay, well, what I really need is the moles of carbon. Well, I also know that in 1 mole of CO2, there's 1 mole of carbon atoms, which means for carbon now, I have 0.13315 moles of carbon. Okay, so we're going to look at the same thing with hydrogen. I have for H2O, which is what contains the the hydrogen, I have 1.37 grams, and I know that in 1 mole of water, there's 18.02 grams of water. So I'm going to take 1.37 divided by 18.02, and that gives me 0.07603 moles of H2O. Now you have to be careful here because now in 1 mole of H2O there's 2 moles of hydrogen, right? So that means that for moles of hydrogen I have 0.1521 moles of hydrogen. So now what I have to look at is between my two values, 0.13315 and 0.1521, which do I have more of? Which one is the lower value? I'm sorry. So the lower value is the 0.13315. So that's what I'm going to divide by. So I'm going to take 0.1521 and I'm going to divide it by 0.13315, and I get 1.14 as my value. Okay, well that's not a whole number of moles, so I have to figure out by what value am I going to multiply that by. And so I'm going to multiply both of them to get a whole number ratio by 7. So that becomes 7. That becomes 7.99, which I can round to 8. So my chemical formula then becomes C7H8. So that would be my formula for the toluene. Okay, so let's try another one. The second one I have is isopropyl alcohol, a substance sold as rubbing alcohol, is composed of carbon, hydrogen, and oxygen. So now this time I have carbon, hydrogen, and oxygen. And it is completely combusted to produce carbon dioxide and water vapor. And it tells me that 0.255 grams of the isopropyl alcohol produces 0.561 grams of CO2 and 0.306 grams of water. We want to know what the empirical formula of the compound is. Okay, well, this one's a little bit different because I know that my carbon that was here, all of it had to go into the carbon dioxide. And for my hydrogen, I know all that was here had to go into my H2O. But my oxygen is in everything. But I also know this time the mass of the whole thing. So if I know the mass of the whole thing, and I can find the mass of the carbon and the mass of hydrogen in that compound, then I can find the mass of the oxygen. And if I know the mass of the oxygen, I can find the moles of the oxygen. So that's the plan that we're going to follow. So we're going to start like we did last time. We're going to start with the CO2. So I have 0.561 grams of CO2. I know in 1 mole of CO2 there's 44.01 grams. So I'm going to take 0.561 divided by 44.01, and I get 0.01275 moles of CO2. And I know that for every 1 mole of CO2, there's 1 mole of carbon atoms, which gives me 0.01275 moles. Okay, I'm going to need this number, but what I also need to do is I need to figure out how many grams that is. So I know in 1 mole, there's 12.01 grams of carbon. So that gives me 0.153 grams of carbon that's in the original compound. Okay, so now I'm going to move on to the hydrogen. So for H2O, I have 0.306 grams, and I know in 1 mole, there's 18.02 grams. So 0.306 divided by 18.02 gives me 0.01698 moles. But remembering that in 1 mole of water, there's 2 moles of hydrogen. So for hydrogen, I have 0.03396. And again, for this time, I need to figure out how many grams I have. So I know in 1 mole of hydrogen, it's 1.008 grams. So times 1.008, and I get 0.0342 grams. So now to figure out the oxygen, I'm going to take the mass of the CHO, which is 0.255 grams, and I'm going to subtract from it the sum of the mass of the carbon plus the mass of the oxygen, of the hydrogen, and that's going to give me the mass of the oxygen. So it's going to be 0.255 minus 153. So I have 0.0678 grams of oxygen. So now I need to figure out how many moles of oxygen that is. So I'm going to take 0.0678 grams of oxygen. Now in 1 mole, there's 16 grams. So I have 0.004238 moles, okay, of oxygen. So now I'm going to take my 3 guys. So I have my carbon is 0.0175 moles. My hydrogen was 0.03396 moles. And my oxygen was 0.004238 moles. So I'm going to divide by the lowest number. So I'm going to divide by 0.004238 divided by 0.004238. And I'm going to divide by 0.004238. So I have 0.03396 divided by 0.004238. That gives me 8. And then for the oxygen, for the carbon, I have 0.01275 divided by 0.004238, and that gives me 3. So my formula winds up being, trying to find a good space to write it. I'll write it on top here. It's going to be C3H8O. So that's the formula for my compound. Okay. The next one adds another layer to it. So we have caproic acid, which is responsible for the foul or odor of dirty socks, yuck, is composed of carbon, hydrogen, and oxygen atoms. Combustion of a 0.225 gram sample. So we have carbon, hydrogen, oxygen, and we're going to combust it to give us CO2 plus H2O. In this case, we have 0.225 grams of your sample. We're going to produce 0.512 grams of CO2 and 0.209 grams of H2O. And we want to know the empirical formula, and then we want to know the molecular formula. Okay, so we're going to follow the same as what we did before. So we're going to start with the CO2. I have 0.512 grams of CO2. I know in 1 mole there's 44.01 grams. So that's going to be 0.512 divided by 44.01 gives me 0.01163 moles, and that's of CO2. And I know that in every 1 mole of CO2 I have 1 mole of carbon. So that gives me 0.01163 moles of carbon. And then I know in 1 mole of carbon, there's 12.01 grams of carbon. So I get 0.1397. Okay, and then I'm going to do the same with the H2O. So I have 0.209 grams. I have 1 mole, there's 18.02 grams. So 0.209 divided by 18.02 gives me 0.0116. But in 1 mole of H2O, I have 2 moles of H. So that gives me 0.0232 moles of hydrogen. And again, I need the mass. So in 1 mole, 1.008 grams. So I have 0.0234 grams of hydrogen. So now we're going to take the 0.225 grams of the CHO, and we're going to subtract from it the 0.1397 grams of carbon plus the 0.0234 grams of hydrogen. And I have 0.0619 grams of oxygen. And I know in 1 mole, there's 16 grams. So I got 0.00387. So for carbon, we had 0.01163 moles. For hydrogen, we had 0.0232 moles. And for oxygen, we had 0.00387 moles. So we're going to divide by the lowest number, which is 0.00387 moles. So that's going to be 1. So we're going to take 0.01163 divided by 0.00387, and we get 3. We get 0.0232, 0.0232 divided by 0.00387, and we get 6. So our empirical formula equals C3H6O. So now let me just make some space here. So now we have to look at the molecular formula. So the molecular formula has to be a multiple of our empirical formula. So we have C3H6O is our empirical formula. Our molecular formula is going to be some value that's going to be times that C3H6O value. So that's going to become our molecular formula. So we're told that the molecular formula has a mass of 116 grams per mole. So the first thing we have to do is figure out what is the formula for the molar mass for the empirical formula. And I get a molar mass of 58.09 grams per mole for the empirical formula. So I have to figure out by what multiple do I need to multiply this by in order to get 116, right? Because then this is going to be whatever that n value is. So my n value then is going to be 116 divided by 58.09, which is going to give us 2. So that means that this value goes from n to 2. So if I take that and I multiply that by 2, I get C6H12O2. And that is my molecular formula. Okay? So what I'd like you to do is we're going to go to the next one. And I want you to pause the video, and I would like to give this one a try and see what you come up with. Okay, let's see how you did. So menthol, a substance we can smell in mentholated cough drops, is composed of carbon, hydrogen, and oxygen. So CHO. And we are looking at combustion analysis. And it's going to produce 0.2829 grams of CO2 and 0.1159 grams of H2O. And we know that we started with 0.1005 grams of the menthol. Okay, so we're going to do the same exact thing. We're going to take our CO2, and we have 0.2829 grams of CO2. And in every 1 mole of CO2, there's 44.01 grams. So 0.2829 divided by 44.01 gives me 0.006428 moles. And I know for every 1 mole of CO2, there's 1 mole of carbon. So that gives me 0.006428 moles of carbon. And then I know for every 1 mole of carbon, there's 12.01 grams. So that gives me 0.0772 grams of carbon. We're going to go back to the water. I have 0.1159 grams of water. In 1 mole of water, there's 18.02 grams of water. .006432. And in 1 mole of water, there's 2 moles of hydrogen. So I have 0.01286 moles of hydrogen. And in 1 mole of hydrogen, 1.008 grams. Gives me 0.01297 grams of hydrogen. So now for the oxygen, we're going to take the 0.1005 grams and we're going to subtract 0.0772 plus 0.01297 grams of this is the carbon and this is the hydrogen. 0.1005. I get 0.01033 grams of oxygen, and in 1 mole of oxygen there's 16 grams. So that gives me 0.000645 moles of oxygen. So we're going to take the moles of carbon, which was 0.006428, the moles of hydrogen, which is 0.01286, and the moles of oxygen, which was 0.000645, and we're going to divide by the lowest value. give me 20. And this gives me 10. So my empirical formula is C10H20O. So now we have to figure out our molecular formula. So let me just look at our difference between them. So our empirical formula, the molar mass is, I get a molar mass of 156 grams per mole. And it said that the molar mass of the molecular formula is 156 grams per mole. So that would have to mean then, since the molar masses of the empirical equals the molecular formula, molar mass, then that means that this formula, the C10H20O, is both the empirical and the molecular formula. So this is empirical, so it's molecular, and the empirical formula equals C10H20O. So I hope this video was helpful for you, and we'll work on some more in class.